Hi again. Hope you are all safe and your families are safe, and hope that you are taking the right precautions, washing your hands, leaving your shoes outside the house, not going out or interacting with any people unless necessary. And I really hope that everybody is safe. So today we're going to actually discuss two concepts. We're going to talk about the chain rule and we're going to talk about something else called implicit differentiation. By the end of this lecture, I think you will be ready to solve the assignment on WebAssign. Let's start with the chain rule. The chain rule concept comes from the example that you can see. In this example, you have 1 over 1 minus x squared, and you have also a square root. Let me look, where's my laser pointer? Let me first activate my laser pointer. Here it is. Alright, so we have actually two functions, if you think about it. Alright, let me first rewrite this one as in this format. It's always easier for me to do the square root as half. And then because it's in the denominator, so you have to put the negative sign. So he's telling you, for example, differentiate 1 minus x squared to the power negative half. We already took the rule for the power. If I have any power, I will take it, put it on the side, and then I will subtract 1 from it. But again, I have another inner function, which is 1 minus x squared. So it's going to be minus 2x. But how to write these two different differentiation forms in one format? So the concept or the main idea comes from this one. It tells you that you're going to use the inner function, like 1 minus x squared, and you're going to call it u. Alright? And then you're going to differentiate it. So you're going to do du by dx. Then you're going to get the other outer function, okay, and you're going to call it y, and you're going to differentiate it, and we call it dy by du. And then if you multiply both of them, dy by du, this one, by that one, du by dx, and you cancel the du by du, you will be left by dy by dx, which is what we are looking for. Alright? Or we're going to do something else, which I think most of you know it this way, which is when you differentiate a function that is actually a composed function, alright? So f dash of x equal f dash g of x, okay? So I'm going to do the outer differentiation, then I'm going to look at my inner function and redifferentiate it. Alright, we're going to take examples on this and examples on that method. We're going to do both. So let's do the first one that I was telling you about. I have 1 over square root 1 minus x squared. I will reorder the equation. It's going to be 1 minus x squared power negative half. The first step is to look at the inner function. Inner function is 1 minus x squared, and you call it u. And then you differentiate it with respect to x, so it's gonna be minus 2x. Step 2, okay, write the outer function in terms of u. So the outer function is the negative half, but write it in terms of u. So y equals u, which is the inner function, 1 minus x squared, to the power negative half. And then you're gonna differentiate with respect to u. So the negative half will go down, and then u to the power negative 1.5. Alright, and then I will rewrite u as 1 minus x squared. I took it from step 1. So it's gonna be minus half 1 minus x squared to the power negative 1.5. What is the last step? Last step, multiply both formulas. I multiply du by dx times dy by du. So he just multiplied the two terms, and here is the differentiated term. The same thing, another example, y equals sine square x. I will rewrite it. Why do I reorder my function, or why do I rewrite it? Because I want to make sure what is my inner function and what is my outer function. So this is an easier way. So I made it equals sine x all squared. So my outer function will be the square, my inner function is sine x. So let's do it. My inner function is equal to u. I differentiate, sine will be minus cosine x. My outer function is u squared. And then the differentiation will be to u. And then I'm gonna substitute u with the sine x. And I'm gonna multiply them together. Alright. Is there an easier way to do the power and the chain rule? Yes, it's much easier rule. The rule tells you that if you find any function to the certain power, okay, what you're gonna do is you're gonna do the power first, the power function first. So if I have u power n, I'm gonna have the n down, and then u power n minus 1, and then I'm gonna differentiate this inner function u. All right? So here it is again. I have gx, differentiate a function to the power n. So I'll do the power first. The power n will go down, and then it's going to be the same function as it is, will not change anything, to the power n minus 1. And then I'm going to look at this inner function in the bracket, and I'm going to redifferentiate it. Okay, let's take an example. 2 minus x plus x squared power 8. Right? First I do the power, and then I do the inner differentiation. So the 8 will go down, and I write the function as it is. I will not change anything in it. And then I will subtract 1 from the power, and I will redifferentiate what's inside. 2, 0, minus x will be differentiated as 1. X squared will be differentiated as 2x. Alright, and then this is, you simplify it, and then write it in a simplified format. Let's try to do this one. This one is what? I will reorder it, or I will rewrite it in a way that makes it easier for me. So it's, for me, I'm going to write it as x plus x power half, all function to the power half. Alright, and now he's looking for the derivative. The answer, you will find it in the next page, but I want you first to try to do it by yourself. How about this one? Well, first, there's certain rules that I need to apply. This is a quotient, right? So I need to do down derivative up minus up derivative down. But where is my chain rule? It's going to be applied here. The derivative of the down, x squared plus 1 all power half. How about this one? See how many functions we have in this one? How many? Well, we have the tan, we have the square, we have the sec. Which one we do first? We do the power first, because this one is tan sec t all squared. So you do the power, and then you do the tan, and then you do the sec. Alright, so this is the first example. So this is the function I want to differentiate. I rewrite it in an easy way so that I can differentiate it easily. So I just wrote it as x plus root x all power half. So what is the differentiation? The first thing, what do I do? Half goes down, and then I write it as it is, half, and then x plus root x, and then I subtract 1 from the power, times the derivative of the inner function. So it's times the derivative of x plus root x. Alright, then in this step, since this is going to be half minus 1, is going to be negative half, so I took this term down and I put it here. So it's going to be 2 and the term, but in the denominator, the square root in the denominator. And then now I need to do the derivative of x plus the derivative of root x. Derivative of x1, derivative of root x, it's x power half, half will go down, and x power half minus 1. So it's going to be x power negative half, and here is some re-simplification of the same equation. Alright, another example. Here it is, just a differentiation of a quotient rule. This is the first thing you need to check before you do the differentiation. Is it product rule, is it quotient rule, or it's just like a single term? So here we have a quotient rule, so you have to do the rule. The differentiation of a quotient thing, or a function that has a numerator and denominator, is down squared, and then I'm going to do down derivative up minus up derivative down. Follow the steps and check your answer. Is it correct or not? I don't care about the simplified one. I just want to make sure you did the right differentiation. Now, this is C. How many functions do you have here? You have tan sec t all squared. Okay, so how many differentiations you need to do? So the first thing you need to do is the power, the square. Here it is, 2, and then you write it as it is, tan sec t. And then you do the derivative of tan sec t. What is the derivative of tan sec t? I'll first do tan, which is sec squared of the function sec t, and then I'm going to again look at sec t, which the derivative of it is sec t tan t. So here, how many things did you do? You did 3 things. 1 for the square, this was the first thing to do, and then you derive the tan to sec squared, and then the sec, you made it as sec tan. Check your answer. Make sure you did all the right differentiations. Okay. This is another topic that we're gonna talk about, but it is very easy, and again, it has to do with the differentiation. Okay? In certain equations, an equation like this one, for example, he tells you find the equation of the line tangent to the circle. This is the equation of the circle, by the way. X squared plus y squared equals z squared. At a point 3, negative 4. Alright? To find the equation of the tangent line, I need the slope. To find the slope, m, it's y dash. So you have two options to find y dash. Either you solve for y and then find the derivative. What does that mean? What does it mean to solve for y and find the derivative? It means you say that y squared equal 25 minus x squared, and then y equal positive or negative square root 25 minus x squared, and you solve the derivative for both the positive and the negative term. Or, which is the easiest way, and this is what we call the implicit differentiation, we find the derivative by doing differentiation to this function. Like x squared is going to be 2x. Y squared, what is the differentiation of y squared? The differentiation, because we differentiate dy by dx, so everything has to be with respect to x. So if I have x, I have no problem, it's going to be 2x. But if I have y squared, I have a problem. The y squared, y is not the term I'm differentiating with respect to. So whenever I find a y dash, I have to put, whenever I find a y, I have to put a y dash. So y squared will be 2y, just a simple differentiation, but I have to put a y dash. Alright, because this is not the term I am doing the differentiation with respect to. And then the 25 will be 0. This is called implicit differentiation. Why it's implicit? Because the y, alright, the y is inside the function. It's not explicitly found. It's not on one side and the rest of the equation on the other side. It's in the equation itself. So we just differentiate the whole equation. If I found y, alright, if I find z, if I find t, I have to put their differentiated term. So if y, I have to put y dash. If t, I have to put t dash. Alright, since I'm differentiating with respect to the x. This is the first option. If I apply it, it's going to be like this. This is the equation. Alright, and this equation will give me two functions, one positive and one negative, and I have to differentiate both. This is the second one, if I do implicit differentiation. So I'm not gonna get the y on the left side and the rest of the equation on the right. I'm just gonna differentiate whatever I have in my equation by the same order. So x squared will be 2x, y squared will be 2y, don't forget the y dash, 25 will be 0. Then I get the y dash on one side and the rest of the equation to the right. So what's coming here is that I did 2y y dash, which is here, will be equal to negative 2x, and then y dash equal minus 2x over 2y. Take the 2 out, it's going to be minus x over y. So this is the y dash, right? And did he give me a value for the x and y? Yes, he did. So I just do direct substitution, and this is the value of the y dash, or the slope that he is asking for. Alright, right here, find dy by dx of the following function. Again, I have the y inside, it's not on one side. After he asked for the differentiation, he said also find the points where the tangent is horizontal or the tangent is vertical. So here, points mean find x, y. Okay, let's do the first step. Find the differentiation. It's going to be what? Let's try to do it right now. Y cubed, 3y squared y dash plus, what about this one? 12xy. Remember, you always need to go to the first rules. Is it a product or a quotient? This is a product. It's x times y. So it's going to be x, y dash, derivative second, plus second, derivative first, plus y, derivative x is 1. And the 12, you can take it as a common factor before you do the differentiation. Plus 3x squared equals 0. This is the way it is. This is what we did. And then you get y dash on one side, the rest of the terms on the right hand side. So this is the differentiation of the function. What's next? He said, what if the slope is horizontal? If the slope is horizontal, this means y dash equals 0. So the numerator will be equal to 0, which is this one. What is the slope is vertical. Then the denominator has to be equal to 0. So let's do it. If the slope or tangent are horizontal, I have to set y dash 0. I took the numerator of the derivative and I equated to 0, and I found that y equal minus x squared over 4. I rearrange this one, alright? Always rearrange so that the square is on the right hand side, because if you get x in terms of y, you're going to get two functions for the x, because it's x squared, so it's going to be x equal plus or minus. But right now I'm just having one. Then what do? I go back to the original equation. The original equation, the y cubed plus 12xy plus x cubed equals 0. Because if I have a function and I have a slope, both of them have the same points. So I can go back and substitute. So I will substitute and I will write y as minus x squared over 4. Here it is. Y became minus x squared over 4, and I'm rewriting the equation with the substitution. Then I will solve for x. I will say that this equation equals 0. I will solve for x. I will find that x equals 0 or cubic root negative 128. Then I will resubstitute in this equation. Since I got the x, I can easily get my y. So my y will one be 0, and in the other one will be minus 6.34. And these are the 2 points where the tangent is horizontal. What about if the tangent is vertical? I have to set the denominator to be equal to 0, because vertical lines don't have a slope, right? So I have to make it undefined. So I have to take the denominator as 0. So I will do the same steps of the previous one, but I will set the denominator equals 0. So here is the denominator of the derivative. And then I got a relationship, x equal minus y squared over 4. I went back to the original one, which is this one, substituted with x equals y squared over 4. I solved for y. And guess what? I found that it's just the opposite of the previous points. Okay? And then I got the points where the tangent line to be drawn is vertical. Alright? Can I check the graph? Yes, this is the graph of the function. Looks a little bit strange. Okay? Let's check the things. We said that we have a horizontal tangent. I can draw a horizontal line at 0, 0 and negative 120 cubic 128, which is 5 point something, and minus 6.34. Let's check. Horizontal slope at 0. Yes, here it is. I can draw horizontal slope at 0. Let's check this one. It is minus 5 point something and minus 6.3. It's this point. Can draw horizontal line, so that's correct. What about the vertical tangent? Can I draw a vertical tangent at 0, 0? Yes, I can. I have here another slope that could be drawn vertical. What about minus 6.34? I think it's here. And minus 5.0 something. It's this point. Yes, I can draw a vertical line here. So I am correct. Okay. Breathe. This is another example. I hope you are not bored by now. Find equation of the tangent line to this curve. Okay? And then he said at the point, question mark, I don't know the point, and y equals 0. Okay? By now you should know the steps. Find equation. I need x and y. I need m. M is the derivative of this function. This function is implicit differentiation because I have the y inside. This is what I'm going to do. Equation of tangent line y minus y1 equal mx minus x1. This is the general equation for any straight line. And then I don't know what is x, I know y equals 0. What can I do? I will substitute in the original equation. Substitute y equals 0, you will find the x equals 2. Good. What's next? I want to find the m. M is the y dash. The y dash, I need to do the derivative of the function. Alright? The derivative of the function is this one. I did it. You will find the steps of the next slide if you want to follow it. But this is the derivative. What do? I substitute x equal 2 and y equals 0 because I know that these 2 points lie in the slope. I found m equal 12. So I say y minus 0 equal 12x minus 2, and this is the equation of my tangent line. These are the different steps of the differentiation of the function. These are two sources that you can check on YouTube. The same professor, I really like him. One on the chain rule and one on the implicit differentiation. If there's anything you miss or don't understand, go visit him. He's very good. Go visit the website. If you have any other questions, please email me or get in contact with me. I think by now you are able to solve the homework on WebAssign. I think it will be easy. There's a lot of stuff in the homework we already went through. If you have any other problems, just send me. And I'm considering doing Zoom for people who have problems with the homework so that we can have more online one-to-one conference. Keep safe, and I hope to see you soon.